This example is giving you a differential equation. That's just a fancy math language saying they're giving you a derivative here. So they're giving us this derivative, and they want us to determine a specific solution at this specific point. So the solution to a differential equation really just means getting back to your original function. You're starting with your derivative and you need to get back to the original function. And so what that means is you're going to need to take an indefinite integral here. So we'll take the indefinite integral, the antiderivative of this derivative that they gave us, and then we'll do it with respect to x. When we get out an indefinite integral, we always end up with a plus c at the end of it, right? That's always this constant. And that's what we call a general solution when we get out the plus c. This problem is giving us out a point that actually has to be on our graph. So we'll be able to use that specific point to end up finding out what our specific plus c value is for this problem. When we go back to our antiderivative now and look at what we need to do, there's really just a bunch of stuff being added and subtracted. And so that tells us that we can just apply our power rule for antiderivatives. And that's just a two-step process. It just tells us we need to add 1 to the power, and then we go ahead and divide by that new power. Applying that in this situation, we would add 1 to the power. We end up with x to the 4th, divide by that new power, that'd be a 4, plus add 1 to the power, we get 5x to the 3rd, divide that by that new power. Then we've got an unwritten 1 right there. We add 1 to that, we get negative 7x, add 1 to the power, divide by the new power. Numbers by themselves, when we were taking derivatives, numbers by themselves, constants went away. When we're undoing derivatives, we give them a letter back, so they gain a letter back. And then we put this plus c at the end. What we have right now, this is a general equation of our original function. We just undid our derivative and got back to the original equation. And so here, what you're going to do now is you're going to use the point that they gave you. So they give us the point 6, 586. And what that's telling us is when we plug 6 in for x into this equation, we need the answer, the y value, to come out to be 586. And so that's what we'll do. We're going to do f of 6. We know that when we plug 6 into this equation, everywhere we see an x, so 5 times 4 to the 3rd over 3, just keep plugging it all in, right? Squared over 2 plus 3 times 4. We know that whatever that math is plus c has to equal the answer of 586. So we just do a little bit of algebra to find out what that plus c value is. You can take all that, pop all that into your calculator, and then out of there what you're going to get is 576. So we know 576 plus c needs to equal 586. Go ahead and do one more move of algebra. We're going to subtract 576 over to the other side. We're just solving for c right now. And we end up getting out of here that c equals 10. So our final answer on this, our specific solution here, you're going to take your general solution and you're going to plug your specific c value into it. So our final answer here is going to be f of x equals x to the 4th over 4 plus 5x to the 3rd over 3 minus 7x squared over 2 plus 3x, and then our plus c value is 10, so we put plus 10. This is our specific solution. This is what's known also as an initial value problem. So we got out the specific solution based upon the initial value they gave us that had to be on the graph. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.